Handling the communication of both our hands throughout the game can quickly become a heavy task. Luckily, we have a good starting point to make sure this is taken care of, and we can use the current system in place to build up from. Let's check how input from our Oculus Touch communicates through our player controller to our pawn and eventually to BP Motion Controller. Open Motion Controller Pawn Darts. We'll begin with talking about active communication. We have previously talked about how our teleportation works and the act of us telling the pawn to tell BP Motion Controller to begin searching for a teleport destination. When we press our designated input, our player controller is telling our pawn to call the appropriate function. Our pawn then explicitly tells BP Motion Controller to call a specific function. This is an example of active communication. To demonstrate this another way, we'll use the BP pickup cube as it's already made. We just need to change a couple of things inside of its blueprint. First, navigate to our VR pawn folder and add _darts to the pickup actor interface. This will just make it easier to find within a blueprint. Open BP Motion Controller and look inside of the Get Actor Near Hand function. Zoom into the Does Implement Interface function. We'll just want to quickly make sure that the interface is correct. If you mouse over the interface, we can see that it says Pickup Actor Interface _darts. So it is using the correct interface. Open BP Pickup Cube. BP Pickup Cube is located in Virtual Reality BP, Blueprints, and BP Pickup Cube. Open the class settings in the top toolbar. Add Pickup Actor Interface darts to the interfaces that it is implementing. And compile. Because Pickup Actor Interface darts is a direct copy of the original Pickup Actor Interface, we could just replace Event Pickup and Event Drop with the new ones. Make sure the event pickup that you bring in is from our Pickup Actor Interface darts. So it seems the second one is. And compile. After bringing in the new ones, don't plug them in yet. We'll explain what is happening here in a bit. Drop a BP pickup cube into the map. I'm actually going to also increase its scale a bit so that's easier for me to pick up. Press play in VR, but don't press any controller button just yet. Approach the pickup cube and put your hand close to the cube and feel how the controller rumbles when it makes contact with the cube. This is happening because the cube, which is a static mesh, is currently simulating physics, and the collision sphere on our hand, when overlapped, checks if the other actor that it is overlapping is a static mesh and is simulating physics. If so, it will rumble the controller. Here is an example of passive communication based on specific parameters. There is no direct reference nor explicit calls. Open the function grabActor inside BP Motion Controller. This is called when we press the grab input on our touch controller, which is assigned to the grip buttons. When this function is called, it first calls our getActorNearHand function. It gets all the actors that are overlapped in the grab sphere and whether or not they are implementing a blueprint interface named, in this case, Pickup Actor Interface _darts. And if so, it checks the distance from the grab sphere, and if it is close enough, it will set this object as the value for the variable nearest overlapping actor. Then, the grab actor function will check if the returned value nearest mesh is valid. In this case, it's simply asking if it has a value, and if so, calls the function in the Pickup Actor Interface _darts pickup. The actor we are picking up can be anything so long as it is implementing the correct interface and it is using the pickup function. So, plug in event pickup and drop inside of BP pickup cube. And compile. When pickup is called, it turns off simulating physics and attaches the object to the provided attach to input, which in this case is the motion controller. At drop, it turns back on physics and detaches from the hand. This quick succession of activating physics and detaching is how we can throw the objects. Let's try it out. So I'll teleport up to the cube and pick it up. Now I'm able to pick it up and of course throw it. All of what we've been discussing and demonstrating is the underlying logic we will use to create our dart game. We will need to know the object we are overlapping with is what we think it is, pick it up and place it in a certain way in our hand, and when ready, throw it where we are aiming. Don't underestimate the power of passive communication. Not only does it assist with many tasks that would otherwise be cumbersome to set up, but it can allow us to grow and easily change the task of our project. Now it's darts, but we can use the same logic of passive and active communication for countless interactions. Next, let's take all of what we've learned and create the blueprint for our dart.